Popular depictions of Mars often present a luxurious, high-tech destination, a second Earth waiting for the right architects to arrive. Underneath that digital polish lies a freezing, airless, and entirely lifeless desert. The public has been introduced to a specific brand of science fiction optimism that glosses over the physical constraints of the Martian environment. Landing on this surface initiates a survival struggle defined by extreme engineering and a constant deficit of basic biological needs. One common assumption suggests that once we arrive, we can simply build greenhouses and plant crops directly into the Martian soil. The red dust is saturated with perchlorates, highly reactive chlorine compounds toxic to human thyroids and plant biology. Sustainable farming requires an industrial-scale solution, chemically washing millions of tons of dirt to strip the poison before any seed is planted. Survival on Mars begins with a massive chemical reclamation project against the ground of the planet. This aesthetic of the transparent glass dome is a staple of space-age design, promising a life lived under the open Martian sky. Physics makes this architecture impossible. Mars lacks a global magnetic field and possesses an atmosphere less than 1% as dense as Earth's. Without these two layers of planetary shielding, the surface remains under constant, lethal bombardment from high-energy cosmic radiation. Spending a lifetime behind a thin sheet of glass on this surface would result in a fatal cumulative radiation dose. Solving the radiation problem requires putting meters of solid mass between humans and the sky. Future cities will likely take the form of industrial mining colonies carved directly into the Martian bedrock to use the planet itself as a shield. The first generations of colonists will spend their lives as subterranean miners, working in high-pressure environments deep beneath the dust. Humanity must adapt to a permanent life underground, just to secure the most basic protection from the environment. Terraforming is often described as a gentle, centuries-long process of introducing biology and slowly thickening the air. The thermodynamic reality is far more aggressive. Creating a breathable atmosphere requires a massive, rapid injection of heat to trigger planet-wide global warming. The primary scientific proposal for this heating involves a direct, orchestrated strike on the Martian poles. This plan calls for the detonation of thousands of high-yield thermonuclear weapons over the ice caps. These explosions are designed to instantly vaporize the polar ice, releasing vast quantities of frozen CO2 and water vapor to trap heat within the atmosphere. It is a strange paradox of engineering. The most destructive technology we have ever created may be the only tool capable of forcing a dead world back to life. Reshaping Mars is a centuries-long war against a hostile environment. To see more of the gritty reality behind space exploration, hit subscribe.